All the air maps we have taken.
Okay.
My God, I got 35. I get 36.
Okay. How is that going to help?
Because you gotta plug it into your equation.
What equation?
Yeah, on your chart.
Sine of 2x is 2 sine of x cosine. Sine of x would be negative 3/5. Cosine of x would be negative 4/5. Everyone agree?
So does that mean cosine 2 theta just equals 1?
So 12 times 2 is 24, 24 25ths. Everyone agree? Any questions about that one? Thank you.
Bless you.
Oh.
What about cosine?
Let's use this one. 1 minus 2 sine squared.
Okay. 1 minus 2 sine squared of... Would it have mattered which one you used?
Not really.
Sine is negative 3/5.
Yes.
Sine at 9/25 times 2 is 18/25. And 1 minus 18/25 is 7. Any questions about that so far? And then tangent, you have two options. You could use sine and cosine, or you could use a tangent double angle identity. It doesn't matter. You would get the same thing. It would be faster if you divide those two. I'm just going to use the tangent double angle identity just to practice it. So,
3 tan theta. Or 1 minus 10.
okay, and tangent of theta is 3/4. Is that right? This one, on this particular problem, it might not be a bad idea to go do this one from the original. Kind of could be a check and balance, make sure you didn't make any mistakes along the way, because we know the original was tangent, so just make sure I didn't draw my triangle wrong or anything like that. 3/4 squared is 9/16. Maybe, but should you be able to do this without one?
Yes.
Now this particular one, yes. So if it were non-calculator, I would choose one. This is what you could do. 9/16. Well, really, any of them you could do. You might have to side note do some multiplication. 1 minus 9/16 is 7/16. Flip and multiply. 24/7. Everyone agree?
Yes. Yes.
Does that make sense with our 24/25 divided by 7/25? So we worked out the same either way. Okay, so the half angle identities are what we're going to look at today. That problem you were asking me about, Bryce, this actually is in the textbook somewhere. This is the proof of the half angle identities. Isn't it in the textbook somewhere? Did anyone notice it?
Yeah, I've never seen this.
Okay. No, I mean the answers in the textbook.
How about the look?
No, the proofs to the half angle identities are in the textbook. So this is in the textbook, and you could probably use that to help you. So there's a couple of ways that we can do this. This is a textbook proof of the half angle identities. So what they start with is the double angle identities. Right. We know that cosine of 2x is 1 minus 2 sine squared of x. Everyone agree? With a little bit of rearrangement, wouldn't sine of x be plus or minus the square root of 1 minus cosine of 2x over 2? everyone see how that works? How would you get one for cosine instead of sine? How would you get one for cosine instead of sine? Can I use the other double angle identity for cosine? Does everyone agree? If I use the cosine 2 cosine squared minus 1 instead of 1 minus 2 sine squared, rearrange it, that would give me a half angle identity for cosine. And then the third one, tangent, there's a couple of ways you can do it. You could just do sine divided by cosine, right? That's probably the most efficient way to do it. So, this is to prove, I again believe this is in your textbook. These are the half angle identities. You do not have to memorize them. So this one we derived on the last page. Again, it is literally a rearrangement of the double angle identities. Does everyone see what I mean by that? It's going backwards, getting a half angle instead of a double angle. The cosine of A over 2, very similar proof would get you to that one using 2 cosine of theta minus 2 cosine squared theta minus 1. Tangent is this one divided by that one, the 2's divide out. So that's where you end up here. With some rationalization, with some trig identities, that's what brings us to these two options. If you multiply by a conjugate on top and bottom, you've got sine squared. That's how that does two would come out. So those are the half angle identities. You do not have to memorize any of them. If you ever are expected to use them, you can look them up. But I would argue theoretically you can figure them out using the double angle identities. Would you agree?
Completely.
Theoretically.
That last step with the change the 2x to the A to 2x, that doesn't really.
Okay, let's stop here. Okay, ignore the bottom part. If I wanted to know an angle, like if I want to know the sine of 22 and a half, what is that half of? 45. So you see how I would use the double angle identity rearranged to make that happen. I could find using the double angle identities backwards. Does that make sense?
Kind of, yeah.
So all they're saying in here is instead of x being x, they're saying let a equal to 2x, well then this would be half of that. They're just saying this angle is half of that one in general. Does that make sense?
Yeah.
So they just took the double angle, rearranged it with the three negative. So instead of saying this is just like tomato. This is half of that, or that's double that. We're just saying it. Okay, so how are we going to use these? By the way, keep your trig reference sheet close because we don't have these memorized. So you're going to need to look at it. So I want to find the value of sine of 22.5 using the half angle identity for sine. So I got that half angle identity. Everyone see where I'm getting at? Did we find those on your sheet?
Yes, sir. Okay.
Yeah, right? So how can we use these? Now, again, we could use them in the double angle format, but I want to find the exact value of sine of 22.5. I don't know the exact value of sine of 22.5, but I do know the sine of what? 45. So isn't the sine of 22.5 the same as the sine of 45 over 2? Isn't it 22.5 half of 45? So when you're using that half angle identity, you're going to say, well, what is this half of? Is that helpful to me at all? And it is very helpful because some nasty simplification, but that's okay. Any questions so far? Good so far? So this is plus or minus the square root. What's cosine 45?
Square root of 2 over 2.
What do I mean? We've got some nasty simplification to do. Okay, we gotta get a common denominator on top and then flip and multiply, or you can use the trick I taught you earlier in the year. I could multiply 2 on top and bottom. It's up to you how you do that. I don't care. You will end up in the same place. One way slightly faster than the other, but not a huge deal. Would most of you do common denominators? Okay, so common denominator on the top. 2 over 2, so I get 2 minus radical 2 over 2 divided by 2. Flipping and multiplying, I get 2 minus radical 2 over 4. Everyone agree?
We have to multiply both top and bottom by 2, right?
If you're doing it the way I would do it.
We have to multiply the bottom part, the bottom 2 by 2.
Where you did. I didn't do that. I did a common denominator.
That's not like the whole fraction. Don't you have to multiply both the numerator and denominator by 2? So,
This one.
yeah.
This, 2 over 2.
And the bottom part of that.
Yeah. Because I'm just getting a common denominator on this.
Okay.
So now the other way that y'all said you didn't want me to do it, I could multiply the top and bottom by 2. Which takes me straight down to this stuff. Which works great too. So yeah. But I was just common denominator flipping. You'll need to see the flip and multiply step. What is the square root for? It's not. I've said 2.
It's 2.
Thank you. I could. There's really not anything else I can do. It's nasty. It is rationalized. So we can stop there. Any questions about that? Quite as nasty as it was. Half angle answers will look pretty yucky in exact format. Now I know that I could do this one with a sum of difference. I probably would after today. But it's 75, half of something good. Half of 150. Again, after today, if you wanted to do this with sum of difference, it works that way to 35. However, could you have done 22 and a half with sum of difference? No, because there's nothing that adds to the 22 and a half that's not safe. So we had to use half angle of 22 and a half. But this one you have options. If I were picking... Oh, by the way, I need to go back here. We're not done. We're almost done. Plus or minus is why. Why is it plus? It's in quadrant 1, 22 and a half is in quadrant 1. It's that definitely a positive. Sorry about that. Okay, your tangent of 150 over 2. Which of the 3 identities you want to use? The one that's on the sheet. 1 minus cosine of u over sine of u. Did I lose anyone on that plus minus thing on the last slide? Yes. Okay. Sine of 22 and a half. What is that positive? Where is 22 and a half? Quadrant side is first quadrant. So what's sine of the first quadrant? Positive or negative? Positive, right? we know it's the positive answer. We got two answers because of the square root part. Okay, cosine of 150. Can I find that? What is the cosine?
Negative radical root 2.
What is the sine of 150? A little bit of simplification. Turns out tangent ends up being the easier one on having like a because there's no square root involved. I still need a common denominator though. 2 over 2. Are we doing common denominator, everyone? 2 plus radical 3 all over 2 on the top with a common denominator. Everyone agree? Over 1/2. Flip and multiply that 1/2. 2's cancel and I just get 2 plus radical. That is the same answer that you would have gotten if you used some difference on this tangent. Or 75. Any questions about that one?
How do you just get 2 plus root 3? I mean, it is good.
So that's 2 over 2 and then the negative. Question. Okay, so very similar to some questions we've been asked before. So backwards. So I know that cosine of s is negative 3/7 and s is in quadrant 3. Find the sine of s over 2, the cosine of s over 2, and the tangent of s over 2. Oh, do that.
Why can't I say
Okay, I will need a triangle in quadrant 3. That is a cosine is negative 3, hypotenuse is 7, which means the third side is not.
radical 40?
It's not real pretty. Square root of 40
Negative.
is negative, which is what reduced.
2%.
Perfect. Does everyone know how we got that? Got a 4 and a 10. Square root of 4 is 2. Okay, that's great. Now look. Okay, use the identity for sine of s over 2. And sine of s over 2 is plus or minus the square root of 1 minus cosine of s over 2. Any questions so far? Sine is luckily not too horrible. Does everyone agree? It's cosine is nice. It's negative 3. So. Y'all okay with how I got the plus 3/7? Good. 7 over 7 plus 3 over 7 is 10 over 7. Divided by 2 is
5.
square root of 5 over 7. Everyone agree? Any questions about that? Good. Okay, I need to deal with the plus or minus, and I would like to rationalize. I'd like to get rid of the radical 7. So, rationalization first. Multiply by. Let me show another step. Miller area. This is 7/7 plus 3/7, which is 10/7. Divide by 2, which would be the same as times a half. And so, reducing 10/14ths. You're welcome. I could multiply by the square root of 7 on top and bottom. And so I get the square root of 35/7. Any questions so far? Reference that half angle identities understand. That's what we're doing. And you will not have to memorize them. So you just have to do all work. Let's go find out, or see if we even can find out. I know that S is between pi and 3 pi over 2. Does everyone agree? So where is half of S? If S is between pi and 3 pi over 2, where is half of S?
Less than.
Okay, in fact, isn't it between pi over 2 and 3 pi over 4? Wouldn't it have to be? Because half of pi is pi over 2, half of 3 pi over 2 is 3 pi over 4. So half would have to fall in that interval. Well, where is pi over 2? Where is quadrant 2? Does everyone agree? So, again, a mental note that, side note, S over 2 is in quadrant 2. Keep that in mind for all the rest of my answers. I don't have to decide that again later. Does that make sense?
Yes.
Eric, do you have a question about that? So everyone see how I know what quadrant we're in? So if I know that S is between pi and 3 pi over 2. So let's work with degrees for a minute. 180 and 270 degrees. Then half of that angle would have to be between half of each of those values. That makes sense?
Yep.
Because I can half, right, half 180 is 90, half of, what was the other one, 180, or 270 is 135, so I've got to be between those two values. Because double the value was between those two, half would have to be in those values. So, if I'm in quadrant 2, what is sine in quadrant 2? Positive. We're going to say that is positive radical 35/7. Okay. Let's do cosine. This will be from scratch. Get those edited. See how it will work. Okay, so cosine of x over 2. Now, at this point, I will tell you, you could draw a triangle in quadrant 2 and find cosine and tangent, couldn't you? Now that you know sine. But for Abby and Mackenzie, I'm going to work this one as if I haven't worked any other parts. But there are other ways to find the others if you do have to find all 3. So everyone know what I mean by you could draw a triangle in quadrant 2?
Yep.
Since you know sine of S over 2 is radical 35 over, radical 35 over 7. You can do the Pythagorean theorem and find the third side. 35, or 49 minus 35 is 14. So radical 14 would be the third side. So I really hope that's how my cosine is up, but we'll find out. So we're doing the exact same thing we did on the last one. We're going to use the cosine half angle identity. Top right hand corner of your sheet. So if I want to find cosine of S over 2 and I know cosine of S, the problem gave us cosine of S was -3/7. So I'm going to plug that in right there. So I get plus or minus the square root of 1 minus 3/7. 7 would give us 4 over 7. Divided by 2 would give us 4 over 14 or 2 over 7. I can rationalize that, right? When I get radical 14 over 7, imagine that, right? Is that what my picture would have gotten me also? Again, so once you get one of them, you could do all of the others based on that one. Or you could keep going with more. It's totally up to you at that point. So radical 14 over 7. Well, am I positive or negative? Well, based on my picture, now that I know I'm in quadrant 2, negative. Questions about that? So, tangent. Do you want me to do it the long way just for fun?
No, yeah. Yeah.
Yeah, just for fun. Just in case. Tangent of x over 2. But as you know, once you get 1, you can find all 3 from the picture. The one on your chart is 1 minus cosine of s over 2 is over sine of s. There are 3 options for this one. If you watch the video, you'll see the 3. But this one's probably the easiest of the 3, so that's the only one that made your chart. Cosine of s is negative 3/7. And then sine of x, I would have to go. This is the first time I needed that first picture, isn't it? So someone at the very beginning said, I gotta draw a triangle. Maybe. I haven't actually needed it until just now. But we did draw it at the very beginning. The negative 3/7. And so sine would be negative 2 radical 10 over 7. On the top, I get 7 over 7 plus 3 over 7, which is 10 over 7. Okay, if I go ahead and flip and multiply, times 7 over negative 2 radical 10. Oh, some may cancel, but not that. The 7's canceled, 10 and the negative 2 reduced to negative 5 over the square root of 10. And then I can rationalize that to get negative 5 square root of 10 over 10, which yet again reduces to negative square root of 10 over 2. Yep. So let's go see if our other way would have worked the same. Tangent would be opposite over adjacent. Does everyone agree? So radical 35 over negative radical 14. Any questions so far? You have 2 options at this point. You can go ahead and rationalize and then reduce, or you could reduce before you rationalize. If you are working without a calculator, you would want to reduce before you rationalize. Since these are both under a radical, can't I reduce them? 35 and 14, do they have anything in common that I could go ahead and divide out? 7. So that would reduce to square root of 5 over negative square root of 2. Which, when you rationalize, you get radical 10 over 2.